In designing our mitigation, we'll have to add features to reduce water runoff from our two watersheds. And I talked in an earlier set of videos and slides about how we might add forest canopy. Well, here I'm going to show how we might change the pervious, impervious surface areas to increase the pervious area and hence infiltration, and some considerations that might make this go a bit more smoothly. You don't want to run through the analysis many more times than you have to because it's a long analysis. And so we'd like to get a ballpark estimate of how much water we're saving when we add a particular feature. So to do a impervious to pervious conversion, I simply load up my pervious data here, my surface permeability data, and then I digitize areas that are in a impervious type and call them a pervious type. So here we see I have a area that I've digitized here that is a parking lot, and I've converted it to a type pervious. So it is impervious in the original data, and I digitize a split here of the polygon. So as you might remember, I select the polygon by clicking on it, and then I go to the edit window, and in the edit window I select my modify features. In the modify feature then I can select to split a feature. So I can split a selected feature by clicking across from the outside through the inside and back to the outside to form a new polygon. And that's how I digitize this parking lot, and then I edited its attribute values to make them pervious with a perv code of 1. So I switched it from impervious to pervious for the type. Same thing for this parking lot here. And then for this stretch of road. Now, why did I pick these three areas? Well, they were large, they were impervious, and they're in the soils area where the soils that have a fairly high rate of absorption. So this lobe of soils is somewhat excessively drained, and so I'm going to get a maximum infiltration rate of 0.057. So rather than convert areas where the soils aren't very pervious, they don't have a very large infiltration capacity, I picked those two because they do have a large infiltration capacity. But how much are they going to absorb? For my watershed, the 2.5 centimeter level of rainfall, I have 1,000 and 1,500 cubic meters of water that I need to absorb. And how do I get an estimate? Well, I can do that by, for these new areas, so here are the three of them, exporting them. So I select them and export them, and then calculating some limits, rough limits on how much water might be absorbed. So here I have a model that shows that. Basically, I have the soils data and my pervious addition data. Now remember, my pervious addition data are just these new pieces that I cut out and switched from impervious to pervious. And so for those, I can intersect the soils and the pervious data. Now remember, that clips the soils data out from the pervious section just where there are those new converted polygons. And then I have an output feature class, and I can calculate the geometry on those, and I'll calculate the area. So if I look at calculating the geometry, then I calculate the area output into the shape area in square meters in my coordinate system. Well, then I'll add a field, and that field I'm going to add is basically one to hold the maximum volume. So if it rained until it saturated the soil, how much is that going to be? And basically that maximum volume I create as a double that's fairly large with a field scale of 2 and a field position of 12. Actually, I can make this different. I could make this 4 or something larger. It doesn't matter as long as I have enough space to store my information to the right of the decimal point. And then I calculate that field. And the way I calculate that maximum field is, of course, the area of my polygon times the absolute soil absorption level. So whatever the absolute soil absorption level for that soil class, and it ranges from 5.87, I think, down to something like 0.9 centimeters, it multiplies that And in my case, these are expressed. They have a data set for soils that express those as meters. So it's 0.0587 down to 0.009 or something like that. So when it calculates the volume, the maximum possible volume, it's the soil absorption capacity times the area of each of the features. So that gives me that max volume. Now I want to also calculate how much it might absorb if I have a 2.5 centimeter rainfall. And this is only an estimate because remember there are some trees there and they are intercepting. Now for these, the trees aren't going to overlap much, but they will reduce the rainfall by some. But nonetheless, I'm just going to say, suppose all the rainfall falls, and I can do an eyeball estimate and say, well, it isn't that volume, it's a little bit less volume than that. But this just gives me a ballpark. So I have to add a field in this case. That's a volume field for the 5 centimeter rainfall and the 2.5 centimeter rainfall. So I'll call the first one volume 2.5, and I get, again, I make it a double or a float. Either one works, and give it a precision. And then I add a field that's a 5 centimeter version. So I basically say, look, how much is it going to store if 5 centimeter rains on top of it? Now, again, there is that intervening amount of interception from the canopy that overhangs these areas for any new canopy I put in. But nonetheless, this will give me a ballish, parkish amount. So then I'll calculate the two fields, and it's as you'd expect. It's the area times my depth. In this case, for the first one, the volume 2.5 is going to be the area times 0.025. That's the number of meters times the shape area in meters. And then I do the same thing for the 5 centimeters, 0.05 times the shape area. And I run it, and then I can look at the table, and that will give me a ballpark amount. So I'll validate. When it's done running, I can look at my soils intersect data, what I'm calculating into. And if I open the attribute table and hide a couple of these fields, I can then basically see that I have calculated my my values here for the water volume and the max volume and the volume 2.5 and 5. And so these are just copies. Actually, that was left over because I showed you by adding the max volume. So it's redundant. You'd only have one of these. In any event, I have calculated these values. So the maximum volume it could absorb if all the rainfall that was falling to just saturate the soil, because I've taken the max times the area, it would be able to hold 130 or 208 or 76 cubic meters. More to the point, at a 2.5 centimeter rainfall, this polygon would hold 58 cubic meters or 92 or 33. Basically, it depends on the polygon, so the bigger ones hold more. And at a 5 centimeter rainfall, it would hold this amount. Now, there are a couple of things you have to take with a grain of salt here. First, you're going to get less than this amount absorbed or subtracted because there will be some intervening canopy. Now, the canopy interceptions are typically lower than the amount that can absorb in, but they might reduce by 10 to 20% the amount of volume that they absorb. And you can get an idea by eyeballing and saying, well, a quarter of the area, a tenth of the area, and then adjust it mentally. The other thing is you have to make sure that there's enough water at these points. So where are they within the watershed so that it's going to absorb that amount? So for example, if you can't put a rain garden in this parking lot and put in the same ground pervious conversion, because then you're counting twice the area the water absorbs into. So if you have these in separate data layers, so if you have basically a pervious addition data layer that can't overlap with a data layer that has your polygons that are your rain gardens, because again, you'd be double counting. But this gives you, again, a ballpark of how much. So if these are all in one of the watersheds here at a 2.5 centimeter rainfall, if I have 1,000 cubic meters to get rid of, at the 2.5 centimeter, counted for something like 180 cubic meters, so I have another 800. And I could do a separate calculation again for the added canopy to get a ballpark estimate, to get a sense of how many of these I have to put in and what other features I have to put in. When we talk about rain gardens, you'll see why it's important, because we have to size the rain gardens carefully, and we don't want to make them too big because they're too costly, or too small, they won't absorb enough. So again, this is a sort of a calculation to give you an idea of when to stop or how much volume you'll need to convert. It ends up at the 5 centimeter, you need to convert almost everything. At the 2.5, you get a way of converting less.